All right, so I think this is recording. Let's take a look here at number 5. You have a polynomial function. It's partially factored. We want to factor it all the way and then answer these questions. If we to select the correct end behavior, let's determine the degree. This first one is a quadratic, it's x squared. This is a quadratic, it's x squared, and 2 plus 2 is 4, and that's an even number. And the leading coefficient is going to be whatever 24 times 24 is. That's definitely a positive number. So it's even and it's positive, so it's going up and up. And that is choice 1 here. The graph, when you're far away from the origin, it'll be going up and up. We don't know how these 2 points are connected, but they're connected in a smooth and continuous fashion. So let's see what's the y-intercept. Well, if we evaluate this function at 0 in this first polynomial, in this first trinomial, we get negative 25. And in the next one, when x is 0, we get negative 10. So that's positive 250, which has coordinates 0, 250. So it's up here somewhere. All right, so let's factor each one of these. So let's make an x for each one. So if we factor this first one, we'll have an x over the negative 10 and 24 times negative 25. Oh, I don't know what that is. Oh, yeah, good, because we had that earlier, negative 600. So 2 values when multiplied together equal the top, but added equal the bottom, or negative 30x and positive 20x. That should do the trick. So let's make a table. All right, first term and last term go along one diagonal. The values that we found in our x go along the other. So let's factor this both horizontally and vertically. So we've got a negative 5 here and a positive 5 here. We've got a 4x here and a 6x here. So this first one is going to factor to 4x minus 5 times 6x plus 5. All right. Let's go ahead and factor this second one, just in case there's a common factor. It doesn't look like there is because I've made the table 4 entries, but who knows. So if we do an x method on this other one, now our middle term is negative 8x, and our first term times our last term is negative 240 x squared. 2 numbers that multiply together but add up to negative 8. So let's see. If we break down 240, the natural breakdown is 24 and 10, but that's not a difference of 2. Let's go. There, I see it. 6 times 2 is 12, and 4 times 5 is 20. So if we make the 20 negative and make the 12 positive, all right. Need this room probably for my table. So my first term and my last term, 24x squared, negative 10. The two values we found in our x, negative 20x and 12x. So these have a common factor of negative 10. Oh, boy, I'm a genius. Look, all of these are even numbers. I should have factored out the greatest common factor first. So if I do that, sorry about that. And now, if I do my x, so 60, yeah, 10 and 6, negative 10, positive 6, and now take the first term, 12x squared, and the last term, negative 5, and the two that we found in the x, negative 10x and 6x. So if we look here, we've got a negative 5 that's common and 1. If we look across here, we've got 6x, and up and down here, we've got 2x. So let's come over here and factor this completely. We have this factor of 2. I'm going to put it out in front. Then we have these two factors, 4x minus 5 and 6x plus 5. And then these two factors, 6x minus 5 and 2x plus 1. So there's our polynomial in factored form. This 2 is not going to contribute towards, when you multiply by 2, you don't get 0. It has to be one of these other factors is going to be 0. So for this factor, if you set it equal to 0, add 5 and divide by 4. And that has a multiplicity of 1. For this one, subtract 5 and divide by 6. Here, add 5 and divide by 6. And here, subtract 1 and divide by 2. So all of these are across, is how they intersect the x-axis. There's none of them that's a touch and turn. So we had 2 negative and 2 positive, and it's crossing, like that. All right, so hey, I hope that helps, and I'll talk to you later. Bye.